the future cockpit will contain three things: a computer, a pilot, and a dog. The pilot is there to feed the dog, and the dog is there to bite the pilot if he touches anything.
Welcome to the Derby Mill series, Intrepid Pioneers of the Next Economy, featuring discussions with entrepreneurs at the forefront of deploying machine intelligence and brainstorming sessions about where the technology may go at the limit.
Welcome to the Derby Mill series, Intrepid Pioneers of the Next Economy. I'm Ajay Agrawal, co-founder of Intrepid Growth Partners, and my three collaborators are Rich Sutton of the University of Alberta, who pioneered reinforcement learning, Sendhil Mullainathan of MIT, who uses machine learning to better understand human decision-making, and Niamh Gavin, an applied AI scientist working on optimizing open and closed foundation models. Rich, Sendhil, and Niamh are all senior advisors at Intrepid Growth Partners. The domain we're exploring in this episode is business productivity, workflows. We're here with the leadership team of AppliedAI, which develops software to enhance the efficiency of businesses by automating their back office processes. With us today are Arya and Phillip of AppliedAI. And with that, let's start the show. So just like we did in our very first session, where we were focused on automating workflows in a factory, here we are talking about automating workflows in an office. And so we'll have a quick description from Arya that will explain. He'll just pick one workflow and he'll explain to us how the workflow works traditionally with just humans, and then he'll explain the parts of that workflow that they've automated. And then there's a meta component to this, which is, there's a fair amount of work in automating the workflow, and so they've got another component where they are automating the automation process. And so he's just going to give a description of two things. First, a specific workflow, one workflow. And then second, some intuition around how they are automating the process of automating workflows. And then Niamh will kick us off with her first comments and questions. So Arya, over to you.
Ajay, thank you. When we first started, we focused only on one workflow, which was the one that was kind of very specific into one deep vertical. And that was kind of one product with its own brand and its own experience that we went through. And then we had one more that, again, with its own brand and its own company and a very kind of deep niche. And very quickly, we started realizing that there's a lot of similarity between these workflows, and the kind of historical aversion to multiple products, or the historical aversion to first, we were villains for a while by focusing on services, right? This was the part of tech that everybody kind of avoided. And kind of the belief that we had was these services now, with the advent of AI, can become more of a product, and we can automate parts of it that we couldn't before. There's a whole bunch of formulas that we have from a first principles thinking on why that's possible. And the example we often give, which is in relation to the product called Opus now. It's our V3 of the platform that kind of encapsulates all these different workflows. Is when you go to the opera and hear Hans Zimmer, or if you hear kind of Beethoven, people think they're various genres, or even hip hop or Taylor Swift. They're actually very similar in the sense that a lot of the instruments are the same, a lot of the humans that play the instruments are the same, the billing processes are the same, the acoustics are the same, the seats and the audience are the same. What's different is the sheet music that they play. And that's basically what we found with these workflows, where around 80% of them are similar. That, I think, is a very controversial statement in our neck of the woods, but it's something that we really believe, that the mechanism that these workflows historically were measured and priced, at least on the services side, being time, is a major disadvantage to the future of labor. And we think, for some reason, as humans, we unitize knowledge work by time, by hour, which is our scarcest resource. And that is I think a vestige of that won't last very long. It should be priced by output. And once we have these workflows automated, we've made it very clear what parts are human, what parts are kind of AI agents and automated, and that results in us paying labor by the output as opposed to in an hour or kind of or weekly. We feel very passionately that the massive increase in productivity that we're experiencing in these workflows and in these businesses has to be shared with labor, and having these parts of the workflows that we go through that have human pieces into it. We think that the kind of augmentation of labor is the way to go, and if we're not careful, we will alienate labor like unfortunately we had in the past a few times. So with that preamble, I'm done. I think I really want to get that out there. It's something we feel very, very passionately about. And I'll pass it to Phil to walk through a kind of a concrete, specific workflow that we have built.
Thank you. So the pattern that we look for is typically regulated industries, and one that's done with either internal or external staff, where there is a lot of documents and paperwork being handled and passed along some kind of very deterministic path that goes from an input to an output. So one example is in the healthcare industry. After you have a medical encounter, take a scenario of an outpatient hospital visit, and you've gone in, you've spoken to a physician, you have potentially got prior authorization for the engagement, you've discussed your chief complaint. There's a sort of format for how these medical records are encapsulated and documented in standard systems like EMR, electronic medical record systems that hospitals typically use. There is some data that captures that encounter, which is multimodal. It has some nice structured stuff that is very friendly, and a whole lot of handwriting, a whole lot of charts, scans, imagery of different kinds. And there is a administrative process that kicks off after that encounter, where someone needs to work out how much we're going to charge. This is typically kind of a post-paid sort of credit risk situation where the hospital has often delivered the service and now needs to recover the cost of that encounter from an insurer or a payer, which could be a government, could be an employer, or it could be self-pay from the patient directly. So there are international standards that codify these encounters that make sort of intended to create simplicity and efficiency in the industry, and in general are quite globally standard. And one such scheme is called the Valuation and Management Framework, which is proposed and administered by the American Medical Association, that takes in all the encounter records and places an evaluation on the complexity, the data that's been consumed, the level of risk of that encounter, and then produces one of 9 at the moment in the latest standard, one of 9 levels of that evaluation and management. And so there's a series of steps. The steps are not well documented in terms of a recipe of actions. It's described what one must do, and there are tables and references and things to look up certain values and establish certain levels. And there is quite a lot of detail in that, but there is not a sort of handbook that's in the knowledge domain of something like a modern LLM. This information can't be extracted in a sort of chat completion type engagement. No amount of prompting and like prompt engineering gets you to a level of fidelity such that a non-domain expert could execute this task. And so in this specific example, the problem is take an input of the medical encounter records and all the associated data, scans, prescriptions from the pharmacy, lab results, etc., and get that to one of these 9 codes, which is just a 5-digit integer. Getting that process is something which involves a number of teams in a department called Revenue Cycle Management, and takes around 10 minutes per case. Some are quicker, some are longer, but most hospitals are budgeting around 10 minutes for this case. So the way that we frame this as a commercial problem is benchmarking that current time investment per case, and then setting goals around what can be achieved, and then delivering those goals through intelligent workflow design, intelligent interfaces, a combination of UI and AI is how productivity gains are unlocked.
Okay, Phillip, thank you very much. And so now, just for our listeners, 2 key points as I hand it over to Niamh. Point number 1 is we asked Phillip to describe to us one workflow for one task, so everyone listening can have a mental model of what a workflow is. In this case, he described a scenario where this is in the world of hospitals and payments, and there's a set of, there's an input, a whole bunch of processes. In many cases right now in the West, all that data he described in terms of the doctor's notes and the scans and the medical records are sent offshore to countries with lower wage labor, and they do that work that he described that takes 10 minutes per case, and then they send back the output, which is a 5-digit, one of those 9 codes, 5-digit numbers. But that singular workflow is representative of thousands and thousands of workflows at banks, for example, to approve a loan, or workflows at insurance companies to approve a claim. There are many different workflows where you have a set of inputs, humans review those inputs, and then generate some output that's specified and that unlocks then a set of actions. And so, so that everyone can just have a mental model for this discussion, we're going to use this singular workflow that Phillip described, so we have a shared thing that we're talking about. But when we're, as we're conceptualizing this discussion, you should be abstracting up from this one example to the thousands and thousands of workflows across every industry that this applies to. So Niamh, with that, I pass it over to you.
Sure, absolutely. And thanks for the background. And unfortunately, as someone for their sins who've worked in health, finance, regulated industries, I viscerally already appreciate it. So yes, you're giving me nightmares just reminding me of the paperwork of the past. But if I start to kind of unpack the technical side, specifically on how you codify these guidelines that you alluded to. So namely, if I understand correctly, I like the approach that you've taken, whereby you're mapping business processes as graphs. So like the nodes as tasks and the edges as workflows, with that kind of task-based clustering. And then on top of that, you're leveraging the attention mechanisms of LLM. So I like that intertwining. I think it would be good to understand, again, just from a tech AI perspective, what is it that enables it? Well, that in a way, that mapping enables it to become a path optimization problem. So the question is, what's learned versus encoded and how? So is it like, have you managed to find in the latent space representation learning from manuals, the hyperparameters are tunable in a differentiable mechanism? Or are you still having to human encode to start with and update? Because whilst the process might be deterministic, as you alluded to, there's always edge cases. So it's always a living model. If you can, Phillip, perhaps unpack that a bit.
So we're in transition from sort of human-created workflows to our large work model-generated workflows. So I'll give a right now answer and then a where we'll be in 3 months answer. So it's important to separate workflow execution from workflow generation. So what I mean by that is the doing of a workflow on a particular encounter, in our example, is deterministic in the sense that we know that we need to pick one of these 9 codes, which is, say, the results-driven nature of the exercise. But we also have to be process-driven. And the constraint of being process-driven is extremely annoying because most of the AI effort in recent times has been to get the right answer with high precision. And reasoning and chain of thought has become very fashionable at the moment. but the level of sort of state tracking and auditability of how did you get this answer is roughly equally as important as what is the answer, because there is a lot of auditing. There's a lot of retrospective stuff saying at the end of the year, the insurance companies and the healthcare providers sit down and reconcile overs and unders and try to settle the books, as it were, for the year. And what happens is a whole lot of cases are output and need to be investigated for what they call over-servicing. Did you provide a too high a service level? Did you do too many tests? Did you prescribe too much pain medication? And therefore, we're not going to pay you, or we're going to pay you less, so there's going to be some adjustment. Or is it the other way, where the hospital is under revenue and then has a business sustainability problem, which is kind of the problem in reverse. So there's a kind of equilibrium, and there's a little bit of game theory here for the sustainability of the industry, and there's different countries have different versions of this problem. But in terms of workflow execution, we have these probabilistic steps that the nodes in the graph don't always behave as we'd like them to, because there is generative AI involved, for example. And so half of the magic here is the deployment of humans in all the right places across the workflow execution. So a lot of customers and kind of people new to this are looking at the promise of sort of supervised automation, which is what we call this fusion of humans and AI into workflow execution. They look at this from the problem of, okay, if you're 80% accurate, that means that 80% of the time, the case can go straight through and no one needs to review it. And 20% of the time, it needs to be reviewed. And this is the default mental model of all of our counterparties in the industry when we start. And the journey that we need to take them on is, we'll save you 80% of the time, but it won't be in that dimension. It will be that each case will be sort of 80% faster, but they will all need human reviews. And this is not the answer that people want, but this is the answer that delivers cost savings without compromising accuracy. Because a conversation a year ago when we were speaking to customers, it was, what's your accuracy? And what's the percentage? And this conversation is a very fraught conversation, and no one really wins in an accuracy-orientated conversation. You can't spend accuracy at the supermarket. You can't put it into your stockholders report at the end of the year. No one cares about accuracy because it doesn't drive cost out. What drives cost out is less human hours per case. And so the technical challenge becomes, how do I disperse my humans across the process, which in the graph terms is, I've got these nodes, I've got these edges. Where do I put the human nodes so that my sum total of error is at least more accurate than the human-only process, but the total human time is 20% of the original time. So I've saved 80% of that human cost. Obviously, there's a small cost of compute in there working against us, so we have to accommodate that cost of compute in the workflow execution as well. So from a workflow generation standpoint, which is the other half of this problem, which is if we have an unseen workflow and we have documentation, artifacts, before and after files. I mean, we'll take whatever we can get our hands on to try to encode, as you say, some representation of what is the task at hand, what do we need. Then we go to our work knowledge graph, which is effectively, in simple terms, a database of kind of all of the workflows we've been able to extract from the world. And this is extremely challenging because they're not written down, almost by design. This is not an LLMs. This is not online in a process kind of recipe format. It describes the cake, it describes the ingredients, but the recipe is hidden. And this has been a source of competitive advantage for these outsourcing companies for decades. And so we need to effectively extract the tribal knowledge, the oral tradition, and the kind of undocumented workflow knowledge, and put that into a data store, which we call the work knowledge graph. And the combination of AI methods plus this graph allows us to generate candidate workflows, which we then optimize and place across human reviews that don't compromise accuracy. It has to be minimum human level, but gets that cost function down to as low as possible.
Got it. No, that makes sense in terms of it's like a play of the classic human in the loop, but how do we most effectively use your scarce time in a manner that creates a win-win for all? And there's also a reason why so many of the other AI agent companies have kind of started with anything but regulated and will grow into it, where you've decided to kind of start in the hard place and then go down. I suppose one kind of follow-up question to that before handing over to others is, where do you decide to sprinkle in Gen AI and why? As in, how much can you do with traditional software? As you say, it's UA and AI, right? And kind of just traditional supervised machine learning. Where do you need the Gen AI? Where do you think it adds value and solves a critical part of the hot path that the other tools couldn't?
On the first point about sort of the best place for the humans in these workflows, it's usually prior to sources of compound error, where we're going to use, say carrying forward some mistake across a workflow. This is the most important place to put humans. In our experience, the sort of self-healing design pattern of like self-identifying, some meandering through a workflow execution away from the intended sort of path is pretty lackluster right now. And what we want to do is make sure that where there are those sources of generation, which are essential, and I'll come to where it's used, that we shut down that sort of imprecision as quickly as possible. Now, sort of in terms of averages, that it might be that there's some human sort of early on in the workflow to deal with extraction level issues, and that sort of multimodal translation into sort of friendly content that we can deal with. So if we get that wrong, then we know everything else downstream is very likely to be wrong. So we typically have a human there, and we typically have a human towards the end. Think of it as quality control and creating like useful data for a learning loop later, is being able to make sure that what we're sending out to the customer is as good as possible. So they're very common. And then in the case where there are branches in the workflow, or where there is a source of carried forward error, we'll place other humans. Now, when we build the work graph, we actually, that's a knowledge graph, I should say, we actually, as features, we trap the sort of probability of that being a source of compounding error. And not all tasks are created equal. Just in terms of our sort of nomenclature on this, a task is the node. A task is a series of instructions. The instruction is kind of the subatomic particle that is like makes up what's possible at the sort of atom level of the task, and then the workflow as the molecule, to just extend the analogy. We need to be able to know what are the building blocks we have available that can't be kind of cut, sort of pre-World War II at least, can't be cut any further, so that we know what we have to play with. And they're effectively commands. If you think about it as an operating system, they're the commands that are available. The task composes those commands with what we call glue. It's effectively like adapters and things that make that an executable code block that can be containerized. That is given features and effectively metadata around, what it's going to do, its name, its like cost data, and like high level information, which helps the workflow generation and execution orchestration steps. And then that gets sort of summed up into workflows.
So let me pass now to Sendhil, and then we'll go to Rich. Sendhil, over to you.
Great. I figure if I should do 2 or 3. Each I have 3, and 2 of them have jokes. I think I'm going to stick to the ones that have jokes. So I'll start with the joke. I'll start with the first joke. They don't get any better. So if you don't like this, you're not going to like any of them. So the first joke is a joke you might have heard about, a pilot's joke about the future of automation, about the future cockpit will contain three things: a computer, a pilot, and a dog. The pilot is there to feed the dog, and the dog is there to bite the pilot if he touches anything. And so what I want to ask you is, implicit in that joke, obviously, is that there are a bunch of things that, once automation gets going, there's a bunch of things people won't be needed for. And you have a view, at least at the moment we're in, which is that people are needed for these sort of crucial tasks. I think what's wrong with that pilot joke is that when we've actually built at least cockpits as we can today, the key has been around how do you make sure that the pilot is able to intervene when they can? And I think people often take that to mean, how do you keep the pilot alert? How do you make them able? But I think there's a different element. When intervention is needed, or when the human is needed, they need to be knowledgeable enough to be able to act at the time that they need to act. If you start removing the person from some parts of the pipeline, the people that you're getting in now are knowledgeable about the whole thing, so they're able to do your subcomponents. But as this system rolls forward, are the new set of people who come in who never did those other tasks, will they be able to do those subcomponents that you want them to do? In other words, much like we would be wary of having a pilot step in just when they, in the moment they need it, because how can we make sure that we're not setting up a human plus algorithm system that kind of relies on humans to know things that in this system they would never get expertise at?
Internal formula that we have on kind of the price of knowledge work is the cost of communication, of compute, of orchestration, of intelligence, and of audit. And the first three historically were kind of automated with the internet, with cloud computing, with RPA, and now intelligence is being automated because you can rent it with machine learning and AI algorithms. The part that we think will remain human is the cost of audit, which has a few components. So on your analogy around the pilot, one of the reasons that he's also there is because somebody needs to assume the liability of if something goes wrong. Who are they going to sue? Who will sign the audit log of the plane when it lands if anything goes wrong? And that cost of audit, we think, will contrarian, we think will actually go up over time, because it's the only bastion that regulation and government has left. So that they will kind of add more requirements on you. You must have a pilot that has this amount of flying experience, or he must be awake for this amount of time, or the model and the autopilot needs to be also regulated, where in the room you must have a computer scientist and a pilot now, right? So you kind of increase that load. So that cost of audit, we believe, is the price of a workflow is kind of asymptotic to the minimum amount a human requires to get paid to assume the liability of that role.
All right, let's move on to the next Sendhil's next 2 points.
And just 1 point. So how we maintain the quality is each expert on our cloud has a rating. So over time, how much you get paid will increase and decrease on the quality of your review. So there is a cost of being wrong and flippant about interventions.
I'll just add one thing, and then I'll do my second one, and then quickly move on. I think the thing I was partly getting at was just, it would strike me keeping X% of the full pipeline entirely human, so that you are using it as a way to train people on the full task so that they can do the other components, might be a pretty important component from a human capital point of view. Because I think it's very hard to manage a task you've never done.
Just before you move on from that, because one of the key purpose of this podcast is not so much to be in the weeds of how they operate the business today, or even how they're going to do it 3 months from now, but what does this look like at the limit? Yeah. And so when you hear, let's just take the workflow that we've described, you can imagine a world where this is almost entirely automated, and the edge cases it's a very, very small set of edge cases, and it's basically when the machine knows that it's that its confidence level falls below some threshold on a prediction that it's making. So then it passes it to a person, and then that can be very rare. So in other words, the only reason we might have a human is not because we actually need it in order to fulfill performance requirements, but because there's some kind of government requirement. And so in a world where that's the case, where the only reason we have the human is not for performance, it's to meet some regulatory requirement, do you think your process is still like the thing that you're arguing for? And do you imagine that that's already true in place in things that are already automated, like, what you're describing in the pilot case?
Yeah, I think in the pilot case, we definitely see that. And I think it's because I think when we have even just regulation at the edge, I think the regulation serves the purpose that we feel we need some human oversight of something. And I think it's kind of a maxim that it's very hard for a human, just people, forget algorithms, to have oversight of a thing in a very superficial way. They're going to need some training and some regular training. If you're on a plane and you have a medical problem and you find out the doctor on the plane is a medical school professor at the School of Public Health who's never practiced or hasn't practiced in 30 years, you wouldn't be very happy with that. Mm-hmm. It's not a matter of, there is just humans need to have understanding of what they're doing. Boy, I just earned a bunch of enemies at the School of Public Health. Yeah. Good things MIT doesn't have a School of Public Health. I don't care. Let me go to my second question because I know Rich has to get to his stuff. The second one is a cartoon. I've seen many versions of this. I'll read this cartoon. On the left panel, it shows someone sending an email and it says, AI turns a single bullet point into a long email I can pretend I wrote. And on the right panel is someone reading an email saying, AI makes a single bullet point out of this long email I can pretend I read. And I'm saying this because a huge amount of human workflows have this property that they're sort of human-created stuff. Like in your medical example, a physician wrote a bunch of notes. Those notes then needed to be transcribed by a medical coder into numbers. Those numbers probably going to be turned into something else at the other end. But you do kind of wonder, if we look out to the future, as Ajay said, is there just a simpler tech solution that never needed all of this human workflow around? In other words, going back to something we talked about in our first podcast, if we knew there was an algorithm underneath all of this, would the entire workflow be different? Would we not have medical coding? Would we have just had that native to the EHR in the first place? And so how do you think about that? Which is, you could imagine a world where your business is, I'm going to give you the stopgap right now, but I'm also going to give you a whole new workflow that from the ground up is automation focused.
Okay, Rich, let's go to you.
Well, I've been enjoying the conversation. It's interesting how it's evolved when Phillip was talking about into a multi-step process. Like when Ajay started out, he said, we summarize the case, we send it out to a foreign country, and we get back into the number. But really, what you're talking about is a whole sequence of steps, and you want to be aware of each step and perhaps do credit assignment, which step along the way ran into trouble or was errorful. And it's also interesting that at the end, when you don't send it out to a foreign country and get back the answer, you get an answer. It's not really the ground truth answer. The ground truth comes from an occasional audit that follows the sequence. And so this is an interesting flow of credit, the occasional credit. And you also mentioned there are costs at each step. So this makes it very much like a sequential decision problem, which is where my kind of machine learning, reinforcement learning, is potentially very relevant. Cost at each step, sequence of steps, and then a final evaluation in some cases. And I'm also intrigued that you said the whole thing is only taking 10 minutes. Okay, is this still true? The whole cycle is only taking 10 minutes.
Yes, the bit that
at least in some cases.
Yeah, so yeah. That particular benchmark, doing that in a human-only process is 10 minutes.
So the whole sequence of steps still done in 10 minutes. So that means that they'll get lots of experience, and errors can't be too expensive because you've got thousands or millions of them, and so it would be a good place for learning. and for performance-based learning. It would be interesting to do a value-based learning in this context rather than a supervised context, where you're actually looking at each stage, you see a thing getting better or worse, and then at the end you have an assessment of how well you expect the audit would go, and you know how much the costs were along the way, and so you want to minimize the cost plus the expectation of the audit's cost. And so that sounds like a sequential decision-making control problem, and it would be really relevant to try the reinforcement methods there.
And Rich, for listeners who aren't familiar with value-based learning, can you just explain what the difference is between that approach and a sort of more well-known, supervised learning approach?
Well, with the reinforcement learning approach, the learning algorithm takes responsibility for making judgments about what actions were correct, what decisions were correct, and which ones were incorrect. You can't just say, "Oh, this decision cost money," because, well, maybe it did cost money, but it set up the next stage to not cost money, or maybe it cost money, but it cost less than should be expected. Okay, so these assessments of you really need somewhat nuanced assessments to decide which actions were right or wrong. You can't just say anything that cost money was bad.
And so in the long term, Rich, what are the key virtues of that style of learning?
Well, the key virtue is that it's actually tied to your performance. If you want to, how else are you going to express, I want cost as low as possible, but no lower than as possible? You can't do that with a supervised. You'd need a person to make that judgment, and as alternative to using just the costs and the estimation of the cost of the audit. In the limit, and we are supposed to think here about the limit. In the limit, you would do it. The auditors are sort of a funny thing, and the auditors are supposed to, maybe they're standing in the place for something else. Will this have bad outcomes? Ideally, you'd like to get rid of the auditors and replace them by an objective measure of performance. I don't know if that's possible, but in all cases, but in many cases, it's possible.
Okay, let me circle around here. Go back to Niamh and then Sendhil and Rich for any other just general comments on this case. So Niamh, Sendhil, and then Rich. The
key point my side is what Arya alluded to a little bit earlier on, as to how do you do enough but ensure that you don't assume the liability of the actions as well. So that's something just to consider as you go forward. To your point, when it comes back, you've almost given the practitioners a place to point the finger at the end of the day when they're doing the reconciliation. So how do you augment but not assume accountability?
And Niamh, do you have any just conceptual insights of how you would sort of design principles for doing that, for maximizing efficiency or augmentation, while at the same time enabling an efficient allocation of liability?
I think they hit the nail on the head with the auditability, both for themselves to be able to review and do that rollback, but also to demonstrate the black box to others. But honestly, I think a lot of this comes down to the T's and C's and the paperwork up front, and just working with your partners to understand what's really mission critical, where are the red lines, how do you ensure multiple checks around that as you kind of brush up towards them, and those which are an inconvenience, but not necessarily too consequential in terms of revenue hit or fines their side. So it's really the classic, there's no compromise for understanding your customer, their needs, the process, and how to kind of codify the as is into a good real world representation in your model.
Yeah, I'll just say one thing, which I really like, Philip, how you laid out the distinction between the sort of what often people imagine large language models are capable of today, and the sort of chasm between that and what is actually practical, and sort of the careful reliance on supervised learning part of the pipeline to augment the large language model. I appreciated the clarity of that architecture, as I think there are many versions of companies that might have a similar top line, but feels like what's actually you gave me a lot of confidence in what's actually happening under the hood. So thank you.
And Sendhil, anything that jumps out to you in terms of where this goes at the limit relative to all the types of applications where auditability is not so primary?
I think that what I would take a big step back is I actually think as we think about the limit, we have the temptation to keep all the architectures of regulation, liability, and everything fixed, but those change quite fast. And I think the things I would start thinking about is actually not what are the current liability and regulatory regimes, but what should be the ones that should be in place. So I actually would, as you guys get more successful, I actually would be asking myself the question, what ought to be the liability regime in a world that looks like this? And so I'll just give a concrete example. I think much of the stuff that involves auditability and single instance tracing, of course, some of that has to do with the harm of a single person. And that will be there in some examples forever. But a lot of that has to do with identifiability of who made the mistake. But in a world as we move more and more towards automation, the mistakes we'll care about will be more statistical in nature, will be more aggregate in nature, will have a very different property. And auditability, I think, will take on a different flavor. For example, I think one flavor that'll be really interesting would be, I'd love aggregate statistics of where are near misses, where are the kind of problem. So I think we will start to be looking for very different audit statistics that will look very different. And I think getting on top of that will be a very interesting direction for you and the field.
And Sendhil, just pushing on that a little further, and I don't know if you've spent any time thinking about this, what would be the key differences between a individual level of auditability, the type that we use now, and an aggregate style of audits that are focused on the statistical averages? How would that change the development pathway of a company like this?
So, I'll give an example. So let's do medical coding. Right now, what you might be worried about as an insurer is sort of policies where I upcode a lot, I upcode here, I upcode there. But let's just suppose for a minute the algorithm perfectly does the coding. Then I think as an insurer, I'd be more worried about the inputs into the coding, which are something the doctor did upstream, which the algorithm is just taking as given. So then what I'd be interested in is more questions along the lines of, are there different properties of the instances in each bins for this system, health system, than in that one? I'd be looking for, in other words, I think you have to step back and ask, where is the room for malfeasance that the audit is attempting to deal with? And there's always some malfeasance that audits deal with. Audits don't just exist because we want to audit people. They exist because we worry about bad behavior of bad agents. And so I think to me, it's when you automate, the bad behavior hasn't gone away. The bad behavior has gone somewhere else. So I think it's that we have to trace further back and get rid of the rule and ask, what is the kind of bad behavior in the new system we would be worried about?
Thanks, Sendhil. Rich?
Well, I just want to second what Sendhil is saying. The rules of the game are maybe clear, but they may change. And I would think it would behoove you guys to pay attention to what the real overall, maybe societal goals are that are leading to that auditing procedure, and be aware how that will make the auditing change and as over time, as it succeeds or fails, and the possible errors move to a different part. So the goals may change. So I want to second that. So maybe the implications for your company is to be flexible about the rules, about what the final objective will be, what the final auditing evaluation will be. The other thing I just wanted to mention, and I really like the idea that you start with this massive things that are processed by a generative AI system to develop summaries, and that can save a lot of time. That resonated with me as well. Thank you very much for telling us about your company, your processes.
Excellent. And Rich, just one more for you, which is, if they were to adopt the style of learning that you described,
yep.
So value-based learning, and they are able to do credit assignment on the steps along the way. And so let's imagine that they migrate ultimately to a much...
So what would that be like? What would that be like? it would be really a framework. You would still have, in this case, you still have audits, and you'll still have people examining the trace, and so you still have people saying, "Oh, I think this decision was wrong. You should have said this instead of that," and you want to be able to incorporate that. You'll still have the auditor going and say, "This was not an allowed decision under those circumstances," and you want to be able to incorporate that. So it'll still be there'll be some supervision that's saying this action was right, this was wrong, or whatever, and that has to be balanced or integrated into the value-based computation. So the values would provide a structure or a framework in which to think about this. So the auditor says you have to do this action. Well, the value of it I was estimating is slightly lower than something else, so I have to adjust those values. Ultimately, I think the right way to understand the decision tree is in terms of values. I don't think there's any real question about that. And the values have to lead to the decisions, and the values will be a little bit more long-lasting than individual choices. And the values, if you are accurately estimated, could be used even to argue against the auditor. That process would lead to less good outcomes than the other choice.
And so, Rich, when you have the auditors providing this feedback as they go along, can we think about that as a constantly evolving reward function? That, in other words, it's not a static reward function, and we're adapting the reward function as we go when we're getting more input from auditors? Well,
yes, to some extent, is that the auditors will change their judgments, and the auditors eventually end up making judgments that cost the company money, or that cost the process money, because there are fines or there are required changes, and so that would be exactly a changing evaluation function.
All right, Arya, Philip, thank you very much. Wonderful to have you here, and just 20 seconds each. Any closing comments on your side?
I just want to echo many of the comments. It's very, very astute, and that I just want to call out the sort of seeking of ground truth in all of these workflows is extremely difficult. And you're absolutely right, Rich, around the outcome of the audit is ultimately the source of truth, but that might come many months or years after, and then the show has to go on. So you're kind of clinging to short-term sources of truth to keep things moving. But you don't get the sort of the benefit for say, a reward or ascribing value until many months or years later, and this creates an operational challenge.
Thank you, Ajay, and everybody for having us on. One final thought is on Sendhil, what you said about kind of at the limit, what happens to human involvement in auditors. I think a lot of the workflows we're focused on is this high cost of error, right? Where it's a human life, or this isn't a chatbot, and the questions I think we're asking are the right ones. We think humans will evolve into auditors rather than being processors. So we got to find ways to kind of watch the machine and manage the machine as opposed to kind of doing the work. So these are the right questions on how do we regulate that? How do we think about that? I think, humans will start focusing more on the protein as opposed to the carbs, more and more, which are the edge cases and kind of what ends up happening. And a lot of the workflows we're building for are legacy admin that were built for human-to-human interaction, which will also evolve. So I'll leave you with this last stat that 50% of the time of a physician is spent on non-revenue generating and non-medical tasks. And 50% of your insurance premium is just admin. So that will kind of lower over time as we answer these questions.
Arya, Philip, thank you both very much. Thanks for joining us.
Thank you. Thank you for having us. Bye-bye.
And that's our show for today. Thanks to Rich, Sendhil, and Niamh, and a special thanks to Arya and Philip of AppliedAI. We've also posted links to our hosts and guests' social media feeds and web pages in the show notes, as well as our podcast webpage. Thanks everyone for listening.
The views, opinions, and information expressed in this podcast are those of the hosts and guests and do not necessarily reflect the official policy or position of Intrepid Growth Partners. This content is for informational purposes only and should not be considered as financial, investment, or legal advice.